review stuff from last year that you haven't seen in a while.
Just stuff.
Math.
Make it up.
Then all those guys, all the grades you'll have from here on out will be in class.
So we're just getting toothpaste and graded now.
Did you grade those tests?
You won't have any more homework. We'll just be reviewing and working on stuff in class.
So my average
Sounds like a
dropped by
plan to
30
me, buddy.
So we'll have 3 weeks of class and then finals. So we'll review for 2 weeks on older stuff. Then that last week we'll review stuff that's going to be on the exam. All right.
Before we review, are you going to tell us what you did?
Yes, I'll have it. I'll have it as we get closer. Once it's all right. So for the bell ringer, we're given that the measure of the angle SRT is x plus 15. So this angle here is x plus 15 degrees. Then we're also told that the measure of SRU, so this big angle, is 90 degrees. We want to figure out what this angle is. How do we do that? Alright, wait, say that again? Alright, good. Now, we're not going to be able to figure out what this is, but you said, what's the bigger angle? So we'll do 90 minus this angle.
That's why I did it.
So, can we do 90 minus x? No. Can we do 90 minus 15?
Yeah.
What's 90 minus 15? 75. So we get 75 minus x.
He's still with him.
What was that? I'm definitely scared.
All right. Today we're going to start reviewing relations a little bit. We'll do relations and then we'll do functions. As once you get to Algebra 2 and even some in geometry, you'll have to be able to graph extremely well. Alright, you'll have to, you'll have to be able to graph so that you can start the actual problem once you get there. Alright, so this is just back to the very basics of relations and functions and graphing. So, the coordinate system. You know that as the system that's formed by the intersection of the x and y axis.
Is this a study guide? Or just a worksheet?
It's just a worksheet. Alright, so the coordinate system is formed by the intersection of the x and y axis. You've seen this before. Now, if we were going to actually determine what the coordinate system is, how do we separate each of the things that are here? So, alright, good. So this is, both things are positive here. X is negative, y is positive. They're both negative. X is positive, y is negative. Now, if we wanted to number them, so in general, we number these quadrants just so we have a quick frame of reference for them so when we talk about them. Do y'all remember how we named them?
We do it in Roman numerals.
Alright, yes, this is the fancy word for this is the Cartesian plane.
What?
The fancy word for the coordinate system is the Cartesian plane. It's just based on whoever came up with the
Sound
idea.
like some kind of chicken.
We name it in Roman numerals.
But we name each quadrant in Roman numerals. So, where did the Roman numerals start?
Somewhere.
On the right.
The top right,
The top right.
that's one.
Yeah.
So, this would be 1, quadrant 1. This would be quadrant 2. Bottom left is quadrant 3, and bottom right is quadrant 4. What?
Are they supposed to start like that?
What do you mean?
Are they not supposed to be start 4 lines?
You mean like this?
That's 4.
That's 4.
One before 5, okay, I get it.
Yeah, that's exactly what it is.
Just a second there.
And then, hey, and then you know what 6 is, right? 1 after 6, or 1 after 5.
Okay. And these are 5.
Yeah. Then what's 10?
Next.
Yep.
Yeah.
Alright, which is the x-axis?
X.
The horizontal one, so it's this one. Our y-axis is this one. And then what is the point called at the intersection of the two axes? So this point here. Alright, the intercept, no, that is not right, but the intercepts are where our graph crosses each axis. We want the point where the two axes intersect each other. Alright, it is 0, 0, but there's a fancier name for it.
The middle.
Where the 0 sleeps.
The origin.
Oh, I remember this.
Yeah.
It's called the origin because it is at 0, 0, but it's also the origin because that's where every time you plot a point, you always start here. So if I want to plot the point 3, 4, well, I'd start here and go right 3, up 4. Or negative 2, 4. I go left 2, up 4. The origin is your point of reference for everything on the coordinate system or the Cartesian plane. What? That's part of the reason we're going back and reviewing too. Alright, now let's look at some definitions. An ordered pair. What is an ordered pair? What does an ordered pair look like?
What's the
2
order?
and 3.
2 and 3, right? What else is what would it otherwise look like? How else would you say it? What an ordered pair is? I mean, there's a bunch of different ways you can think of an ordered pair. I'm just trying to think of I'm just trying to see what y'all think it is.
And what is an order?
Yeah.
What even?
No, not necessarily. They could both be odd.
I don't know.
Alright, an ordered pair is just it's nothing fancy. It's just a set of numbers.
Yeah.
Written x comma y. So it doesn't matter what numbers you use, it's always going to be in parentheses with the x value first, or the x coordinate first, the y coordinate second. And so this coordinate pair tells you where on the coordinate plane, coordinate system, this is located. Then what does the x coordinate tell us, or what is the x coordinate? What's the x coordinate?
The one that goes where it's located.
That goes-
on the horizontal line.
Good. So it may also be called the x value, and it's the horizontal placement. So it tells us where we're going to move left or right.
Is this what our next, like, session is on this on this?
No, we're going to do this for a day or two. We're going to do some other stuff for a day or two. It's just going to be random. All right, what about the y coordinate? What about the y coordinate? What's the y coordinate tell us? The y value, so it's also known as the y value.
Placement on the vertical.
Good.
So up and down.
Yep, it is our vertical placement. It tells us where we're moving up and down. All right, the next definition of mapping, it has to do with the domain range. So we'll come back to that just after we go down to the domain range for a second. Now the domain and range have to go back to the x and y coordinates. But what, do y'all remember what the domain of something is?
This over that.
The domain.
Not this, so the domain, yeah, the domain. Yes, no, maybe.
The area it covers.
That's the room.
No, not necessarily.
Well, we don't.
I did not in this case. I know what you're thinking by domain, but it's not this domain. This domain is just a list of all of the x values. So it's every number that's first in the parentheses.
Wait, did you not do that?
I'm going back to mapping because it has to do with this. All right, the range is similar. The range is going to be all of your y values in your relation. So our y values, and it's all the numbers that come second in parentheses.
Is that the mapping?
No, this is a domain range. I'm coming back to the mapping right now.
Oh, snap.
Because the mapping uses what's the domain and the range.
What's those two eyeballs up here?
That's how we're going to draw the mapping.
I thought they were just too awkward there.
The mapping is how you, is just another way to show what the domain and range are.
Who's the relation?
Oh. Purple.
Oh, I skipped the relation too. We'll come back to that. All right. So I forgot that I didn't realize I skipped the relation. relation is just a set of ordered pairs. Alright, so it's just a listing of different ordered pairs that make up a set.
Attention students and teachers, there's a gray truck parked on the end of the front row out by the cafeteria with its lights on. Thank you.
That's what they worry about.
They're just trying to help somebody out.
So bad,
Alright, now the mapping. A mapping shows how
I remember watching
each element in the domain is matched with an element in the ring.
It says, nigga, it says you know you're straight from the blood.
So, like I was saying, it shows how each element in the domain is matched with an element in the range. So it shows, it's a visual representation of how each of the x values is paired up with a y value. And over the course of the day, there's going to be 3 different ways to show this. This is one of them. This is the one that I don't think y'all have seen much before. You've seen the table. We've used the table before while I've been here. We've graphed before. And then mapping is the one that you don't use very often. You see it. It's good to know. You'll see it. They use it in various other.
Are we gonna use those digital?
Yes, we are.
Oh.
All right. So if let's just say we had the points. 2, -3, and 8, and -1, 8. All right, we're given these 2 points. So our x values are 2 and -1, y values are -3 and 8. What's our domain? Because our domain goes in this first oval here. So we said our domain is all of our what? X values. Yeah. So our 2 x values are what? 2 and -1. But when we make these mappings, we're going to put our x values and our y values both in order from least to greatest. So our smallest number is going to be at the top, our biggest number is going to be at the bottom for both of them. So in our domain, we're going to have -1 and 2. Then in our range, we'll have what? -3 and 8. So, that doesn't really tell us much. That just tells us our domain has the numbers -1, 2. Our range has the numbers -3, 8. But how do we match them up? That's what the mapping does. Well, 2 is matched with which number? All right. Look, so we're given these ordered pairs. 2 goes with what number? -3. So I'm going to draw an arrow from the domain to the number that it matches up with over here. So it goes from 2 to -3. -1 matches up with what? 8, so we would draw an arrow from -1 to 8. Yeah, it doesn't matter. They all could go straight across. They could all crisscross. They could do all sorts of different things for this. It just depends on what numbers you are working with.
You wouldn't have another rain percentage today, would you?
The what?
Rain percentage.
For today?
Yes, you did.
I can find out in a second. I know it's pretty high. When I was looking yesterday. The day before, it was up like 50 or 60%.
Don't look like it's gonna be hot Sunday, you know.
No, there's gonna be no sun today. Alright, so let's look at these examples. So for this first example, we're given a relation. So now, a relation, that's this set. So a set is usually specified by these little braces here. Those things you can never draw, like not the parentheses, but they're called, I call them curly braces.
The brackets.
Yeah,
I
brackets.
never draw those, I need to sit with
They are brackets, but I call them curly brackets because
Parentheses.
in math, there's 3 different types of brackets you'll see. This is like to break up math problems. You're used to parentheses, right? There's also these things that are hard brackets.
I think it's multiple.
Well, all of it means to multiply at some point. And then you have these curly brackets. No, it doesn't.
That's just the normal brackets, but
And so we see these the most. That's what we deal with when we're talking about like adding, subtracting, how we do that. Technically they're a bracket, but we're calling parentheses, right? Now, if I have a math problem, the way we normally use these is if I have like 3 times x plus 4, right? Well, they have different sets of parentheses or brackets, so that now if I want to take this and say I want to multiply this whole thing by 4. Well, it looks really weird if I have another set of parentheses there, right? It's kind of hard to tell. Well, they use these brackets. They use the square ones first, normally. Normally they use those first. And then if they do something else, like if I add 4, then they use those. Alright, so that's how they go. But for our purposes today, these brackets right here mean that this is a set of something on the inside. So all of these numbers or all these ordered pairs inside these brackets go together. Alright, so the first thing we want to do, we want to create a table for these 4 points. Now, if y'all remember, a table is just an XY chart, a T chart, you might have heard it called. So we've got X, we've got Y, and then below it we're going to put our X and Y values. Now, the correct way, the normal way to do a T chart, order of the X's matters. Alright, order of the X's matters. I'm putting all of my X values in order from least to greatest, just like we did in the math. Alright, so my X value is least on the top, greatest on the bottom. So my X values are 4, -2, 2, and 0. What's my smallest X value? -2. Then what's the next number? 0. Then what? 2, then 4. Now, we're going to put in our Y values. But, unlike the mapping, right here, we're not going to put our Y values from least to greatest. We're going to go ahead and match up the Y values with whatever X value they're paired with. So, what Y value are we going to write next to -2? -1. Alright, so I'll put -1. What about 0?
That -4.
-4.
Then it goes on, so we're on.
So what goes with 2?
-4.
What goes with 4?
-2, 3, I don't know.
how do
What
you
goes
make
with-
those numbers mixed up?
What?
I
What'd you
think
say?
I should do two.
Why do you have all the numbers mixed up like that? Why
All right.
don't you
On this side, we want to put the X values from smallest to biggest.
What is 5?
Alright?
Why is it negative one?
Alright, because negative 1's a y value.
Okay.
So when you write a t-chart or a table, start with all your x values from least to greatest. Then we match up the y value that goes with each x value.
How do you know it goes to what?
It's based on our relation. So like, I drew my x values. So then we say, well, which point goes with negative 2? If I go here, negative 2, negative 1, so I put negative 1 here.
Okay, I see.
Then I look for 0. Well, 0 goes with negative 4, so I put negative 4
Okay,
here.
you said it goes, it's just beside the right, that's right.
Or you could say it's the one beside it, yeah.
That makes so much, yeah.
Yep. Or it's just the number that's right next to it. Alright, now if we want to graph these,
We got smoke in my face.
let's remember, so each time I'm going to start at my origin. So the first one I want to graph, 4, 3. So well, if I look over here, negative 2, negative 1. How do I graph negative 2, negative 1?
Left 2, down 1.
Good. Left 2, down 1.
Let's just skip it. I agree with Megan.
Negative 2, negative 1.
She's totally right.
Alright, what about 0, negative 4? Down 4. We don't go left or right any, just go down 4. Then what about 2, negative 4?
Right 2, down 4.
Right 2, down 4. And then 4, 3.
Right 4, down, right 3.
Yep, right 4, up 3. So those are the first two ways to represent a relation. And then the last way is the mapping that we talked about just a minute ago. So for mapping, I'm going to draw my two ovals.
Why does these seats sound like gas stations?
It's just the water going through the pipes. Alright, I got my two ovals. My domain goes in the first one, my range goes in the second one. What's the first number I'm going to put in my domain oval?
Oh crap.
Remember, I'm putting all the x values from least to greatest.
Okay.
So what'd you say?
Negative 2.
Good. Negative 2, 0, 2, and 4. Now, with the range, it's all of our y values, but if one repeats, we don't have to put it twice. So I'll show you how we make up for that once we do it. So how am I going to put my range?
Negative 1, negative 4, 3. I don't know.
Swap the negative 4 and the negative 1.
Why would negative 4 and 3?
Because negative 4, remember, in negatives, the bigger the number, so like 15, negative 15 is actually smaller than negative 1. So, we have 0. Think of it this way. If we go right, we go 1, 2, 3, so on and so forth. If we go left, we count the same way. We go left 1, left 2, left 3. So as we go farther and farther left, the numbers that look bigger are actually smaller. Because it's based on how far away they are from 0. So both of these are one place away from 0. I'm just going positive or negative. Okay? That makes sense? So we're going to do negative 4. I'm just putting it once, then negative 1, then 3. What am I going to draw an arrow from negative 2 to?
I thought it would be negative
Negative
one.
one.
-1. All right, again, just like over here, once we got these, and I matched these up based on which one they're with. The same thing over here. What's -2 beside up here? -1. What's 0 beside?
Oh, negative one.
-4. So I'll draw an arrow -4. So -2 goes to -1. 0 goes to -4. What does 2 go to? -4. What does 4 go to? 3. And so that's how, because we don't repeat, the arrows tell us that, oh, I have two numbers that go to -4. That's why we don't have to repeat any of the numbers. The arrows tell us how many times we
You
go.
get like a 15, like a span of like 15 numbers.
It'll be really confusing, yeah.
I'm sorry, y'all.
Alright, then example 2 says, what is the domain and range? Well, we've already written our domain and range, haven't we? Guys, we've written our domain and range already for this last problem, right?
Yeah.
So all we're going to do is rewrite it in that set notation. Like they did up here, we're going to rewrite the domain and range with those brackets. So my domain is going to be -2, 0, 2, and 4. The range is going to be -4, -1, 3.
Them brackets is so hard.
They are. It's alright. So do mine. Now look, just like before, I wrote my numbers from smallest to biggest in each set of my brackets. Alright, so the last thing we're talking about today are independent versus dependent variables.
There you go.
I don't want to put that new green ball.
Alright, independent variable. An independent variable is the variable that determines our output. So our variable that determines what's going on in our problem. So that's the variable that we're basing everything else on. We've got this one variable that causes other things to happen. And then the dependent variable, well, that variable changes based on our independent variable. So if we look at examples 1 and 2 here, we're not doing 3a and 3b, we're just doing 1 and 2. All we want to do is identify the independent and dependent variables. So, for example 1, it says the air pressure inside the tire increases with the temperature. So I want you to think about these two things. Does the air pressure cause the temperature to increase, or does the temperature cause the air pressure to increase?
The temperature causes the air pressure to increase.
Alright, so whichever one you say first, so if you say the temperature causes something else, the temperature is our independent variable, and what it changes is the dependent variable. So our independent is going to be our temperature. And our dependent is the air pressure. Alright. For 2, as the amount of rain decreases, so does the water level of the river. So does the amount of rain cause the water level to change, or does the water level in the river cause the rain to change? The rain causes the river to change. So our independent is going to be the rain, and our dependent is going to be the water level. What? What'd you say?
If water started raining, though, that'd be awesome.
Yeah, that'd be weird.
That would be kind of weird.
That would be cool, I think, like, do the washing pictures. Just a little bit of must.
You gotta do it.
Alright, so we're done for today. Tomorrow, we'll do some review on this stuff.